Kia ora, Year 13 and Year 12. Here's the first part of the 2016 integration paper, question 3. There's 2 achieved questions and a merit question. Okay, we've got a definite integration problem and we asked to figure out the value of k that will make this equal to 0. So I'm just going to start working with the left hand side and see what we've got. We can rewrite it as 4 plus kx to the negative 2 dx. So I'll work this through first and then I'll set it equal to 0. So anti-differentiating, I'm going to get 4x minus k times x to the negative 1. Right, I have to have a minus here because I need to end up with a plus here. Right, so we can check by differentiating this expression to see that that works. Now I have to put in my limits of integration, which are 4 and 1. Okay, so now I'm going to evaluate that and I get this. So 4 4s minus kx to the negative 1, so that's k divided by x, which is 4, minus 4 1s minus k divided by 1. So putting that all together, we get 16 minus k on 4 minus 4 plus k. So that gives me 12 plus 3/4 k, and now that has to equal 0. So negative 3/4 of k equals 12, and we get k is 48 on negative 3, so k is negative 16. Right, I'm sorry, that's very squished there, but hopefully that all works. Okay, so that was a little achieved question. Feels like quite a bit of work for achieved, but it's straightforward application of what is a definite integral. Okay, on to the next one, which is Simpsons Rule. Right, we're given a table of values and we're asked to find an approximate answer to this. Okay, so we don't need to know anything at all about f of x except what the y values are. So remember, the point of Simpsons Rule is that I'm trying to find the area under some curve, and I'm going to do it by just using a set of points along the way. So there's Simpsons Rule and there's the Trapezium Rule, and they both need to be revised for the exams. Okay, and they're both pretty good at approximating. So we're going to do this. H here is my gap between values. So in this case, h is going to be 0.5. Right, so it's the jump here. Has to be regular. And we can see that's going up in 0.5s. Then I'm going to substitute in. Now, these two, these are my end values. These are my odd-numbered y values, and these are my evens. So it goes like this. The integral is going to equal 1/3 times 0.5 times, let's see, well, the endpoints are 1.4 and 1.8. So they go in once. Then my odd numbered values are going to be this one, and this one. So they get multiplied by 4. So it's 4 times 2 plus 3.8 plus 2.2, and then my even numbered ones, these go in twice. So it's 2 lots of 3 plus 2.8. Right, so we carefully pop all of that into our calculator, and out pops our answer, which is 7.8. Okay, just be careful with your brackets. You might want to pop a few extra lines of working in there. Okay, so there's really not much to it, and just make sure you've gone over that and also gone over the Trapezium Rule. Okay, on to the last part, which is a merit question. Right, use integration to find the area enclosed between the graphs of these two functions. So this is an upside down parabola, and this is a straight line. So this is merit because we have to just get on with it and do it. So here's my parabola, we know that that points 2, and here's the line y equals negative x. Now I'm drawing that pretty badly, but realistically that's what you're going to be doing in the exam. So what do I have to figure out? Well, I know that I want to find this shaded area here. So it's going to be the top curve, 2 minus x squared minus negative x. That's what I'm going to be integrating. But I need to know these meeting points here. So I've got to find my limits of integration. So to do that, I've got to figure out where the two lines meet. So we're going to solve this. 2 minus x squared equals negative x. That gives me x squared minus x minus 2 equals 0. Sorry about the background noise. There we are. There we go. We've got x and x minus 2 and plus 1. Now have a look. Does that make sense? Yes, it does. We've got x equals 2 and x equals negative 1. Right? So that's most of the work done. On the next slide, we're going to pop those limits in and we're going to do the integration. And we're going to work out this number here, which is the area. So notice I don't have to worry about any of the stuff with signed area. If I'm doing the top curve minus the bottom curve, I just get on with it. Okay, so here we've got the integral from 2 to negative 1, and it's notes, so 2 minus x squared minus negative x dx, which equals 2x minus x cubed on 3. Now plus x goes to plus x squared on 2. Here 2 and negative 1. So that gives me 4 minus 8 over 3 plus 2. Right, so that's 2 squared is 4. Take away. Okay, so then here we're going to have minus 2 times negative 1, negative 2, minus negative 1/3, plus 1/2. So just be really careful with the negative ones and the odd and even powers, and then carefully popping that in your calculator. Here we're going to get 6 minus 2 2/3 minus negative 2 plus 5/6. You guys are probably going to do that straight to your calculators, and that's fine. And we end up with 4.5. Okay, so that is a merit question. Just make sure you've gone through how to find the crossover points for problems like this, because that's the key to getting it right. Thanks for watching.